Hey y'all, this is another example on long division of polynomials. So like we stated before, we went ahead and labeled our numerator as the inside and the denominator as the outside. So I went ahead and placed the numerator inside my long division bar and my denominator on the outside. But you can see, this is going to be stated as incorrect form because we're missing a variable inside of the long division bar. So we're actually missing k to the third. We need to make sure that we write these in a descending order, starting from the biggest exponent all the way to when there is no exponent, so a constant. So the biggest exponent we notice is k to the fourth, and we are missing k to the third. So as you can see here, we have it listed, we have it listed the correct way already. So k to the fourth plus 0k to the third minus 4k squared plus 2k plus 5. So now we can go ahead and start actually doing the long division process. And that was stated previously in the first example, but we're going to go ahead and still discuss it and see how we're supposed to make our variables that we're canceling by. So the first thing we notice here is that we have a k squared, and I need something times something to give me k to the fourth. Well, I know that k squared times k squared will give me k to the fourth. So that's what we're going to be placing up here is k squared. So k squared times k squared will give me k to the fourth. And you want to make sure that these turn out to be the same, because remember, we have an imaginary negative that we're going to go ahead and which will cause all my signs to flip. So then we have that. So then now we're going to multiply now. What's 1 times k squared? Well, that just turns out to be k squared. So we're going to go ahead and write it underneath its respective variable. So I'm going to say k squared. So then we're going to go ahead and subtract them, or actually switch the signs. So if we flip the signs, so we notice here that these cancel. And then what's 0x cubed, 0k cubed plus anything? Well, plus 0. Well, it just turns out to be 0. So we have 0k cubed minus 5k squared plus 2k plus 5. Remember, I'm bringing these down with me. So now we ask ourselves the next question. We still have a k. We have k squared. And we can really rewrite this to look like this. We can just get it out of the way because it doesn't change the fact about it right now. So then we'll go ahead and see that when we get this, we're going to get minus 5k squared plus 2k plus 5. So now the game becomes, I need to cancel off a k squared, so I need to multiply by something to get negative 5k squared. Well, I already have a k squared, so the only thing I need to multiply it by now is negative 5. So then that means on the top piece, I have to write negative 5. So k squared times negative 5 will give me negative 5k squared. And then what's 1 times negative 5? Remember, these go to these also. So we're going to multiply by both of them here. So then 1 times 5 will give me negative 5. And you'll see throughout in a couple more examples, I'm going to be posting them up also. You'll see how the pattern it will build up on top of itself. So remember, we have to go ahead and switch the signs before we go on. So we switch the signs. These cancel. I'm left with 2k plus 10. Now I told y'all in the last video that y'all need to know is that when we're going to go ahead and finish a problem is when this k is smaller than this k right now. So is it? Technically, yes, it is, because it's one less of a degree. So I want to go ahead and show you how the answer would look overall. So your answer, or what we would call the quotient, would be written as k squared minus 5, and it has a remainder. The remainder is what you're left with. So this is what you're left with. So this is your remainder, and then this is going ahead to be your quotient. So then our remainder is 2k plus 10. So the way that you want to go ahead and write this, depending if you're on a computer or if you're trying to turn this in paper, you would write k squared minus 5 plus 2k plus 10 over k squared plus 1. This is how you want to write the remainder portion of it. It's got to have the divisor or what you started off with. And k squared plus 1 is what we started off with. So this would be one way of writing it. There is overall another way of writing it, and the other way of writing it would be looking like this. K squared plus 1 times k squared minus 5 plus 2k plus 10. So this is your divisor, your quotient, and then this is your remainder. So overall, any of these should be acceptable. Now it just depends on how your professor's writing it, or depending on what book they're using. So I've seen mostly this one before. So go ahead. If you have any more questions, please let me know. You can go ahead and hit me through email, or you can comment and leave a message. Go ahead. Appreciate it. Thank you very much.